to introduce Marty and Jared, who will be giving you information about their careers and their industries. So go ahead and take it away.
All right. Thank you. Hi, everyone. My name is Jared Brown. I'm with Renewable Energy Group. I'm a senior process development engineer there. I've been at REG since 2012. Can you see the slides? All right. So REG is one of the largest biodiesel producers in the world. Wanted to show this slide. It shows our CEO, CJ Warner. She started off her career as an engineer and worked her way up to be the CEO of REG, which is a publicly traded company. So I think that's just a good testament of engineering as a career with lots of places you can go. We are headquartered in Ames. We recently expanded globally. We have 2 offices in Ames. We're around 300 people in Ames. And then once you include all the personnel at our facilities, we have around 850 employees. Our production network, we have 12 biomass-based diesel plants. The ones in blue are what we call crude feedstock or multi-feedstock plants. They could take a wide variety of materials. I'll show you a little bit about what those are. And then the plants in green take more of a refined feedstock material, but still not edible. So these are all things that we can't eat. And we're taking those raw materials and turning it into renewable fuel to the tune of 630 million gallons per year. We do a little bit of specialty chemicals as well. That's the box in yellow. So what is our raw material? So at REG, it's basically triglycerides, which is fats and oils. So it's waste materials, like I said, that you can't eat or that are byproducts from different agriculture operations. I have some listed here at the bottom. And then what this picture shows is a report we made available to the public, basically showing that really any triglyceride you can turn into biodiesel. It's just a question of, what are the economics with that? What kind of processing do we have to do? Is it, enough of that material to supply one of our plants? But it's a really flexible process. The feedstock starts on the left, and then on the right, you could see the biodiesel, and the color is not really indicative of the quality. These all meet fuel specs. Biodiesel is something that, it's in the pool of diesel. So when you fill up your truck, if you have a diesel truck and you fill it up at the gas station, you're getting a little bit of biodiesel in there, and it depends on what state you live in and the season. But biodiesel is a common industrial fuel. Little chemistry lesson. So I mentioned triglycerides, so that's fats and oils, and it's called a triglyceride because there's 3 fatty acid chains and connected to what we call glycerin backbone. And when you add methanol to that triglyceride, you do a process called transesterification, and you break that apart into 2 things. There's a glycerin that we sell. There's a lot of industry uses for glycerin, and we sell methyl esters, which is biodiesel. So this is kind of a quick overview of the process. Biodiesel, like I mentioned, it's used in trucks. There's some places like in the Northeast, they use home heating oil instead of we heat our homes with natural gas in the winter. In the Northeast, they use basically diesel fuel in a tank in their basement. So people are starting to use biodiesel in that application. We have one other process we use. It's called renewable diesel. So this is an exciting kind of growing part of our business in the industry, and it's more similar to like a petroleum refinery. So instead of adding methanol to our triglycerides, we're adding hydrogen. So that hydrogen splits off the oxygen, and we have a fuel byproduct, propane, and then paraffins get a little bit converted more into a renewable diesel. So this is chemically indistinguishable from petroleum diesel, but it's made from renewable resources. So this is a hydrotreating reaction. Like I said, it's a very growing part of the industry right now. So, REG as a manufacturing company, and like other manufacturing companies, it's not all just technical stuff. I looked on our intranet site because I wanted to see all the departments, and I listed them here. So basically any kind of like professional thing you could think of as a career path, there's manufacturing companies that are hiring those types of people. So it takes people to buy materials, and we're converting it, but then you have to sell that. And then there's all kind of things in between there. So you have to worry about, how are you financing new projects, all the transactional stuff, accounting, tax, legal. But I'm going to focus on just these ones in underlined are the engineering disciplines. Construction is, fairly easy to kind of conceptualize. We have civil and construction project engineers that work with people at REG and other third parties to design things and then actually do a project. So we're putting something new in the ground, new buildings that house new equipment, and that kind of thing. Manufacturing operations is where I've spent the majority of my time at REG. These are people that are day-to-day working with our plants on a variety of things. So it's compliance support. We work with like OSHA regulations, safety, things like that, and then a lot of continuous improvement activities. So what that means is improving the plants in some way. So getting more gallons out of them, getting better yield. So getting the same amount of output with less input, trying new feedstocks. You know, how can we get more money out of these plants, reducing the chemical inputs. So to do all those things, they have to kind of look at how the plant's operating, visit the plant, you know, look at the process data they're generating, understand that, and then be able to make recommendations to the plant on how to either change something or put in some new equipment to make that plant run a little bit better. And then where I work currently is in our technical services department, and there's a variety of people that work in this department. We do fuel testing, quality assurance, testing new feedstocks, testing different fuels, and then specifically what I do is more looking at new things for the future. So we do kind of research on smaller scale equipment, trying to figure out new processes and new catalysts and things that we can eventually, once we're comfortable with it, scale it up to a plant type scale. And then vice versa, if something's not working well at the big scale, like at our plants, we'll test it on a smaller scale in our lab, kind of duplicate something small, like one step of a process, like a filtration step or a distillation step. We'll do that in the lab and be able to look really closely at it and then give recommendations on the plant of how to change something. So engineering careers, I just pulled some data today. So the big four disciplines in engineering is civil, electrical, mechanical, and chemical. REG hires all these types of people. Other manufacturing companies do as well. In the next decade, they're looking to hire 30,000 people. And then I put the number to 1 million people now because that's all those people are always going to need those jobs. So if someone retires, they move to an industry, you have to replace that person. Plus, there's that growth. So these are definitely growing fields. Whereas, you know, as you know, that's not the case with all industries. Some industries are shrinking. Engineering is not. It's growing. These are relatively high-paying jobs, especially for a 4-year degree. I put the median salaries on this last column. So again, half the people are making more than that. This is the median. And so just personally, you know, engineering, I find you're able to, you know, do something meaningful to the world. So we're in the renewable fuels business. So there's benefits there as far as, you know, cleaner emissions and that kind of thing. But every type of engineering is doing something for the world. You're giving back something. You're either, you know, civil engineers are making roads and they're safe and that's allowing, you know, interstate commerce, or, you know, electrical people are working on different things that make life kind of exciting with different technologies and all the cell phones and video games. And so it's just every kind of engineer is doing something that's they find meaning in it to be able to give back to society in some way. So they're meaningful jobs, and they're very exciting because you get to always learn new stuff. The world's always changing. You kind of have to keep up to date with that technology and always learn new things. Then my last slide is just kind of a plug for our internship program at REG. We take it pretty serious. We're pretty proud of it. We did it even this past summer. Despite COVID, we had around 40 interns, which is scaled back. We typically have more than that, upwards sometimes of 60, which relative to our size of the company is a pretty big program. We give the interns real projects. It's gotten good reviews from the interns, and we end up hiring a lot of people that way because we do interviewing for someone that, you know, we would want this person to be here full time. So a lot of interns get offered part-time or full-time positions at the end of that internship. So I know that was a lot of information in a short amount of time, but that's what we have to work with. So thank you for this opportunity, and I look forward to questions and discussion. I think you're on mute.
All right. Let's see if I can get here. Okay. Can you hear me now?
Yes.
All right. Thanks, Jared. So mine's a little bit different. Jared and I did not collaborate on this. My perspective is well, let me introduce myself. Marty Shildroth, and I'm the process engineering manager for the AIM site for Hawk Company. And we are also an international company with roughly, it's about 6,000 to 8,000 people worldwide. And we are a company that works on water testing. So here at the AIM site, we developed the chemistry that's used worldwide, and it goes along with our instruments. Our instruments are produced in our corporate Loveland, Colorado facility, and then also worldwide in whether Berlin or China or Thailand, we have worldwide presence. And my background is I've got just at 30 years of manufacturing experience. I really, really enjoy it. I've been in quality, I've been in engineering, I've been in operations, and currently back into engineering, and have a team of about 12 engineers here on site at the Ames facility. And this group is responsible for a number of activities within the organization here as far as sustaining and new product development. So with that, I'm going to go through my slides and show you, I believe I'm presenting, there we go. A little bit of my perspective on this. So in our operations and how we manage it here, just looking at what our output is, we have instruments that are used specifically for water testing, and whether it's in a municipal water system where everything that we're drinking is being tested by Hawk product, or else going back out into the rivers and streams. So I've got a couple examples of what we produce here, and
Marty,
we also
real
have.
fast, I don't think we're seeing the slides.
You aren't?
Sorry, interrupt.
Okay, let's try this again. How about that? It says I'm sharing.
Yep, I see it now.
I'm going to go to presentation mode. There we go. So just thinking about what our products are, you can see several of the products listed through here. So whether they're instruments or chemistry, and this is the type of material that we produce in our facility. And so we ensure that water is safe for drinking, processing, and environmental. So whether it's a municipal water system or whether it's like the Ames power plant, we make sure that the water purity level is acceptable for processing, and everything. Just if you think about Fairway or Hy-Vee, everything in there has been treated with processed water, and we are responsible for making sure that water is safe. And so we're the global leader in this arena, and there's not many people that currently do this. So it's an interesting business, and just having a worldwide presence is pretty interesting. So just thinking about the 5 inputs into a process. So our machines. So when we think about the things that we need to do to make sure that we have a good process, whether it's design, we're looking at new technologies, we have programming, and a lot of new projects that we are currently working on to be able to process our equipment, or process our materials that we're working on through this facility here. And that's what a lot of our team works on. We also have a lot of material development. So whether it's water or chemistry, and then mixing that together. And then we also have a lot of packaging. So the areas of specifically what I think about when I'm doing this is chemistry and science. So those are the classes that we really want to focus in on, especially in the materials area. As far as methods, So all of these are part of the process inputs. So project management and math and communication, those are the areas that are really important for these types of activities. And then the people, I'm sorry, environment. I'm jumping to environment. So the science and technologies areas, those are really important to make sure that, you know, we understand what's required to make sure our processes are focused. So kind of tying in with what Jared said, a lot of the people that we're required to have to make this place operate and operate properly are all these different types of, and you probably hear about it in your coursework, but the STEM. So the science, technology, engineering, and math. So if you are thinking about positions within HOC, and I'm sure REG, you're thinking about these positions as far as STEM. And as you look on the left side there, you'll see that under the science, we have lots of chemists that work here. And then whether it's in quality or R&D, as far as technology, we have production techs, we've got maintenance, quality, and then even our operators. I mean, they are all skilled folks that require a specific amount of education to be able to manage the processes here. And then like Jared, we also have a lot of need for engineering. So whether it's mechanical, industrial, chemical, electrical, environmental, we all have a great need for technical folks to be able to fill these roles. And then along with math. So we have quality systems, we have statisticians, all working to help us through these processes. The other thing that we have is like our supply chain. And that's specific, and I'm talking specifically in our Ames facility here. Whether it's science, as an analyst, or technology, we have planners and buyers. We have supplier quality. We have analysts and in math, requiring math, and then also IT. So if you're thinking about all the classes that you that would be beneficial for getting a job with us, or I'm sure REG, all these highlighted areas are some of the focuses as far as your coursework to get to where you can be gainfully employed with us. So this is kind of the thing that I think about as far as when we look at how we manage our processes here to be able to have an end product for our customers. And we really focus in on our people and the people development because we have a large quantity of people that work here to be able to manage this organization. So whether it's here or even any other company, they're all thinking about the same types of things. So in your coursework, I think sometimes it's like, I just want to get this done and not have to worry about it. But there is meaning in that, and it does fall in line with what we're currently looking for. Whether it's you're going to graduate and look for a job with us or REG, or go on to a further education, because we have a great need across the board. Whether it's for operators, or for maintenance, for engineering, for technical folks, whether it's in quality, even for higher level degrees. So that's kind of what I wanted to talk about. So that's my presentation.
All right, thank you both. Can you maybe talk a little bit about what could, if I'm a freshman or a sophomore in high school, what could I do now that would help set me up a little bit more successfully than my peers for a potential career in your area?
Well, I mean, if someone knows that they are interested in STEM, I mean, I think taking some classes, early on to help make, solidify that, it would be helpful. So take some advanced science or math and see, do I like this? Do I want to do more of it? Because there's going to be more of that in college. So trying to get a head start on that, I think would be helpful.
And I think about what are your interests, and making sure that you align your interests with what you want to do further in your career, so that you don't go down the wrong path. don't chase the money, chase what's of interest to you, and then focus your efforts and your education to try and align those, so that eventually you're going to have to, we all have to work, and so you might as well enjoy what you do and take advantage of your skill sets and make sure that they align.
Yeah, that's a good point on the skills. I always encourage young people to try to figure out what their strengths are and play to them. There are a variety of kind of little tests you could take to try to figure out what your strengths are, and that's helpful. So if your strengths come out of things like, analytical and learning and those kind of things, then you might, be more inclined to enjoy a career in engineering.
Mm-hmm.
Aside from like academic and technical skills, we talk a lot about soft skills or employability skills. What are some of the top ones that are looked for in your industry?
That's a great question. And we always encourage, young people as engineers sometimes are lacking in those skills because it's just, they kind of sometimes get so much into the academic side of it, and it is a challenging academic pathway, so they sometimes forget those skills. So working in teams, so technical teams, wherever you go, there's always going to be a lot of teamwork. So being a competent kind of team member is a big one. Just in general, like goal setting, trying to figure out kind of where you want to go with your career is important. Also, effective communication is a big one. Being able in manufacturing, both of our presentations kind of show that there's a lot of different people in these companies. They're not all technical. It doesn't mean they don't need to be aware of and understand what you do, but you got to figure out how to communicate with all different types of people, even people in the other presentation, Marty talked about operations folks. So it might be people that didn't go to college. And if you're an engineer, you still have to be able to communicate with them effectively and, in a respectful manner. So effective communication for engineers is a big one and something that you have to work on.
Yeah, and tying in with that, because communication is a big one, but we also have problem solving. So we're both, this is all we deal with every day. So as engineering, everybody comes to us with problems. So, how do you solve a problem? And thinking about how you look at it from the proper perspectives. But communication, teamwork, problem solving, I agree.
And then I guess I'll throw in one more that I kind of just one of my personal ones that's not necessarily has to do with engineering, just in general. I try to share with young people is don't have a mentality of that, that's not my job. So try to keep an open mind. So you might be some kind of engineer, but don't limit yourself in that box. Be open to new opportunities. Try to ask yourself, how can I help, instead of saying, well, that's someone else's job. So try to kind of just keep that open mind of growth and that kind of thing.
Well, there aren't any other questions that came in, so I'd like to thank both of you gentlemen for sharing your information, your expertise on this area. Is there anything else you want to, lasting comments or advice for the group?
Study hard. Yeah, thanks again for this opportunity. And yeah, manufacturing, it's I think it's a great career field to get into in one way or another, or making things, here in the United States. And it's supporting the local, REG supports a lot of like the agriculture industry. So I just think manufacturing is kind of a good, great career field to get into.
I 100% agree, because after being, in the operations for 30 years, you see other areas where, I don't want to do those other things. I want to stay where the action is, and this is where the action is, and it's challenging. It's different. There's something that's after. There's a new problem every day. My employees tell me that the thing that they like about their work is the day is never the same. So there are certain careers that you're doing the same thing over and over and over, and this is not that. So we enjoy that and take advantage.
Well, thank you again so much for your time. And students, thank you for joining us.